Example 14. With what terminal velocity will an air bubble 0.4 mm in diameter rise in a liquid of viscosity 0.1 Newton second per meter square and specific gravity 0.9? Density of air is 1.29 kg per meter cube. Most of the time we see bubble forms in the water go down at the beginning, but soon they start coming up. Many of us had experience of it. In the given problem, we are going to discuss why it would happen. So let's start it. So in this problem, they have given the liquid having coefficient of viscosity, that is 0.1 Newton second per meter square, and the specific gravity is 0.9. Also they mention that the density of air is 1.29 kg per meter cube. Now what we have to do is find the terminal velocity of an air bubble having a diameter 0.4 mm. So let's understand the given problem using following figure. In the given figure, this blue color is indication of this liquid, and this is air bubble will experience three different type of forces. The very first is the force due to gravity because of its own mass, then upthrust force due to this liquid, and then viscous force again due to the liquid. Now as we know, this viscous force is directed exactly opposite to the direction of motion of an object. So here air bubble is initially moving in downward direction, but later because of something it starts moving up. So let's find why it is happened so. So initially the net force on the bubble, which is a downward force, that is given here, Fg minus Fv plus Fu. Now Fv plus Fu, this term is smaller than Fg, and because of that this air bubble will move initially in downward direction. As time passes, Fg and Fu stay constant, but Fv increases with increase in velocity. Now here the velocity of this bubble will increase because of the existence of non-zero net downward force, and because of the increase in velocity this Fv will also increase, and in this way finally a situation happens where the net downward force becomes zero, and hence we will get this condition in which this F is 0, and hence we can write Fg is equal to Fv plus Fu. See this, here Fv will increase such that this force will become a 0. So in this way this air bubble will experience a zero net force, so that it will gain a constant velocity, and this velocity is called terminal velocity. So let's understand more about terminal velocity. Terminal velocity. As bubble is experiencing zero net force, it will continue with upward constant velocity, and this velocity is called terminal velocity. Remember, the direction of this terminal velocity is upward here. Terminal velocity is the velocity where a given object will undergo zero acceleration, and this can be achieved when a given object experiences zero net force. So in this way we will discuss one more term, that is specific gravity, which we have to use while solving the problem. Specific gravity is the ratio of density of a given liquid to density of water. It is also called relative density. Specific gravity is equal to density of liquid upon density of water. As it is a ratio of densities, it is a unitless quantity. So let's solve the final solution of the problem, as they are given that the diameter of bubble, which is d, is equal to 0.4 mm, which can be written as 0.4 into 10 raised to minus 3 meter, and also can be written like 4 into 10 raised to minus 4 meter. Now if we know the diameter, we can find radius easily, that is d by 2, which is 2 into 10 raised to minus 4 meter. Coefficient of viscosity of a given liquid, that is eta, is given here 0.1 Newton second per meter square. Specific gravity Just now we discussed which is a ratio of density of liquid upon density of water, and we are interested in the sigma value, which is the density of liquid. So let's find it. Density of liquid which is equal to specific gravity into density of water. Therefore, sigma is equal to 0.9, which is the specific gravity, into density of water, that is 1000 kg per meter cube. So we will take 10 raised to 3 here. By multiplying with these two terms, we will get sigma is equal to 900 kg per meter cube. We also have density of air, which is 1.29 kg per meter cube. Now let's find terminal velocity of bubble. We have this formula for a terminal velocity of air bubble, that is 2 by 9 into r square g into bracket rho minus sigma upon eta. Now here rho and sigma are the densities, but rho is the density of air, whereas sigma is the density of liquid. So let's substitute the value of the given quantities. What we will have is 2 by 9 into 2 into 10 raised to minus 4 raised to 2. This is the value of r, and here it is r square, so we will take square of this quantity. G is 9.8, rho and sigma that we have to substitute here. Rho is 1.29, which is given, and sigma, which we derived, that is 900. Eta is 0.1. So we will separate out these quantities in this way, where 2 into 4, these 2 2s are 4, and 10 to the power of 4 raised to 2, that is 10 raised to minus 8, that we will keep in outside. So 2 times 4, which is comes out from here, into 9.8 into 1.29 minus 900, which is comes out to be minus of 898.71. So this negative sign we will keep outside, and finally we have a term inside the bracket, which is 2 4s are 8 into 9.8 into 898.71 into 10 raised to minus 7. Now this minus 7 is comes from this denominator. Actually 9 into 0.1, we can consider 9 into 10 raised to minus 1, and we will take this 10 raised to minus 1 in the numerator by considering 10 to the power of minus 7. So finally we have to apply a log table here in order to get the answer. So let's apply the log table. So initially we have this equation, V is equal to minus 8 into 9.8 into 898.7 upon 9 into 10 raised to minus 7. Now we are going to apply a log table for this particular yellow color terms. So log of 8 into 9.8 into 898.7 upon 9 is log 8 plus log 9.8 plus log 898.7 minus log of 9. Log of 8 is 0.9031 plus log of 9.8 is 0.9912 plus log of 898.7 is 2.9536 and log of 9 is 0.9542. By adding these three terms, we will get 4.8479 minus 0.9542. By subtracting 0.9542 from this term, we will get 3.8937. Now this is the answer for log of this term. So let's find antilog of this term. So antilog of this term, it means antilog of this number, which is 3.8937, and its answer is 7829. Finally, we can write minus of 8 into 9.8 into 898.7 into 10 raised to minus 7 upon 9 is minus of 7829 into 10 raised to minus 7, which is equal to minus of 0.7829 into 10 raised to 4 into 10 raised to minus 7. And by using this indices formula, we can write finally terminal velocity V is equal to minus of 0.7829 into 10 raised to minus 3 meter per second. Here negative sign indicates that the bubble initially goes down, but finally rises up. This opposite behavior of motion of bubble is responsible for this negative sign. Thank you.